In this video, I want to have a look at the closest exoplanet to Earth. Now, we've found thousands of exoplanets. These are planets outside of our solar system, so thousands of those, but which one is our closest one? Is it Earth-like? What's it like? And how far away is it? Well, the closest one is Proxima Centauri b, and it's just over 4 light years away, which sounds like a long way because it takes like four years to get there, but in astronomical terms, that's actually really close. So that's a really close planet. Now, to put that into context of the solar system, you can see that actually it's quite close. So this is a illustration of the solar system, the sun's gravitational influence. And it's a logarithmic scale, so you can see if you go across on the x-axis, that is in AU there, so you've got 1 for Earth, then 10 for Saturn, about 100 for Voyager, all the way out to about 100,000, which is the edge of the Oort cloud. That also correlates to about 1 light year, and 1 light year is about the gravitational influence of the sun. So beyond that, the sun's gravitational influence stops, and anything beyond that will be influenced by other objects, other stars. So the Oort cloud goes up to about 1 light year, and we already know that the nearest exoplanet is 4 light years away. So you've got this 1 light year sphere around the sun, which is the gravitational influence, or known as kind of the Hill sphere or Hill radius. And then 3 more light years beyond that, you then have an exoplanet. So our nearest star system noted here is Alpha Centauri, and that's actually made of 2 stars prime mostly, and just before that you've got Proxima Centauri, which then has our exoplanet. So it's not that far from the sun and not that far from the gravitational influence of the solar system or the sun. Now, it's our closest star, so not only is it the closest exoplanet to us, but the star that it orbits is also the closest one to the sun. Now, it's part of the Alpha Centauri system. So I mentioned that Alpha Centauri was a double star and it was located kind of just outside Proxima Centauri, which is correct. So you've got these 3 stars here, which are our 3 closest stars. But actually, they are a triple system. So they are gravitationally bound to one another, despite them having different names. And sometimes you'll note that Proxima Centauri will be called Alpha Centauri c, because it will be the 3rd star in the Alpha Centauri system. So it has different names depending on where you may look, but it is actually a triple system. So it's gravitationally bound, these 3 stars, and we know that we've got a planet orbiting the closest of those 3. So Proxima Centauri is a small red dwarf star. It's considerably smaller than the Sun. Because it's smaller as well, it has a lower surface temperature. So it's about half the surface temperature of the Sun. It's about 3,000 Kelvin compared to about 5,778 Kelvin for the Sun. So it's very small and very cool. That means that it's not very luminous and it's not giving out a lot of energy, which is quite important when you start to look at planets and habitability. So the habitable zone of this particular star is very close to it. Because it doesn't give out a lot of energy, it's not very hot, it's not very bright. The habitable zone, which is where you would have liquid water on the surface of an exoplanet, it has to be very close. Because in order to get that same temperature on the surface, it's just got to be closer to get the same amount of energy. So that's an important thing to consider for this particular planet. So the exciting thing about Proxima Centauri b is it is in the habitable zone of its star. Despite the habitable zone being very close to the star, it's still inside it. Now, it's just inside the outer edge. So being just inside the outer edge, it's actually still fairly cool, because the further out you get, the cooler it's going to get. So whilst it's still classified as the habitable zone, it's still going to be a little bit cooler than the Earth. So about 234 Kelvin, or about minus 39 degrees Celsius or 38 Fahrenheit. So it's still going to be quite a cool planet in comparison to the Earth. Now, because the habitable zone is quite close, it's going to have a very short orbital period. So it has about an 11-day orbital period, and that makes it much closer than Mercury is to our Sun. So Mercury is a very close planet, it's our closest planet to the Sun. and we think that's got a very short orbital period, it's very close to the Sun, but actually this particular planet is considerably shorter in its orbital period or orbital radius. So the orbital radius is about 1/8 of Mercury's. So again, this just puts it into context of our own system. It's a very short orbital period, very close to its star, but it's still actually not very hot. So this is where it starts to get a little bit interesting. So not only is it our closest planet, not only is it in the habitable zone, but it's also almost comparable in size to the Earth. So it's a little bit bigger than the Earth, about 1.3 times the radius and just over 1 times the mass of the Earth. So at least size-wise, it's quite similar to the Earth, despite where it is, which is quite interesting. Now, it's expected to be tidally locked. So that means that you've got one face always facing towards the star. And as it orbits the star, it rotates once for one orbital period. So it's always facing the same direction. Now, the moon is tidally locked because the tides from the Earth have slowed its rotation down and we always see in the same face. Now, stars or planets that are very close to their stars undergo the same sort of process. The tides from the star slow its rotation down and lock it in place so that it rotates once for one orbital period. And these sorts of planets are always expected to be tidally locked. And if they're not, they will become tidally locked at some point as they slow down. Now, that has consequences for habitability. So we know that it's in the habitable zone. We know it's about the same sort of size as the Earth, but because you're not going to get day and night, well, you do get day and night, but it doesn't change like it does on our planet. You're always going to have day or you're always going to have night. That has implications as to habitability. So the face that will always be facing towards the star is probably likely going to be too hot, and then the side that's always in night is going to be too cold. But you then have this rim around where it's not quite night, not quite day, where it might be the right temperature to be habitable. But the consequence of having one day and one night side is because one side is always heated, it can drive quite significant and large winds, which then basically rise up on the hot side and they circulate round to the dark side. They do circulate some energy around, some temperature, and distribute it a little bit, but it causes quite significant winds. That might be a problem, but it could still be habitable anyway. And another problem that we know about red dwarf stars is that they have quite significant flares for their size, and they are continually throwing out these quite large flares. Now, if you've got a habitable planet, we already know that's going to be very close to the star. So chances are those flares are going to strip the atmosphere, they're going to sterilize the planet, and that then makes them uninhabitable, which is a bit of a problem. So we've known this for quite a while, that these red dwarf stars are throwing out these flares. We've got habitable planets orbiting red dwarf stars, which you always hear about. We found some more habitable planets, but more often than not, with a red dwarf star, they're not likely to be habitable because of these flares. However, quite recently, there's been some very detailed observations of these red dwarf stars and looking at where the flares are actually being emitted from the actual star itself. And it turns out that they're actually emitted more towards the poles. So the planets are not orbiting around the poles, they're orbiting more around the equator. So they're not going to get a direct hit. So they could still be habitable. These flares are not going to hit the planets, they're in a different direction. So after all, these planets might be habitable, which actually starts to get more exciting again, because we thought, well, maybe they weren't habitable, but now we know where they're coming from and being thrown out into space. These particular stars may still support habitable planets. So we know that we've got a planet in the habitable zone. It's potentially Earth-like, might be habitable, but it gets a bit more exciting because it's not the only planet. There are potentially 2 more in the same system. So this is the nearest star to us. It has a habitable planet, potentially, but it also has 2 other planets. So our nearest star has a planetary system, and this is quite good because it means that these planetary systems are likely going to be quite common as well. So we've got lots and lots of stars out there. Chances are there's going to be lots more like this. So we have 2 more planets. One of them is very close, likely too hot, and the other one is a long way from the star and likely too cold. So Proxima Centauri C is the one that's furthest away. Now, we don't have a radius for that, and it's a little bit controversial because it was supposedly picked up in radial velocity measurements, but there's been some studies that suggest that the signal that was found that was hinting towards this planet could be an artifact of the data and the way we're looking at it, and it might not be a planet. So I've put controversial there because it's not 100% confirmed and it wants some follow-up work. But if it is real, then it has a mass about 7 times that of the Earth, and that will be classified as like a super Earth or a sub Neptunian planet. So it's going to be quite a cold, large planet, basically. And the reason why it's cold is because it's a long way from the star. So it's about 1.5 times the distance from the star that Earth is. So 1.5 AU. And this gives it a very cold temperature. So you're looking at minus a few hundred degrees here, actually. So very, very cold, not habitable. But then again, how many planets in our solar system are habitable? So now the second of the other 2 planets is Proxima Centauri D. Now this is a bit smaller than the Earth. Well, I say a bit smaller. It's about 0.81 times the radius, but about a quarter of the mass. So it's a fairly small planet. Now I've put here that it's a candidate, again, similar to Proxima Centauri C. It's only been recently discovered, so it basically wants further follow-up work, really. And yeah, it's going to be quite hot in comparison to the other planets. It's very close, so it's 0.029 AU. It's just inside the habitable zone, so it's basically going to be too hot to be habitable. So about 360 degrees Kelvin, 87 degrees Celsius. So we're talking a very, very hot planet here. But still, we only have one habitable planet in our system. So thank you for watching, and if you enjoy, then check out some of the other videos.